The next thing we're going to talk about is empirical and molecular formulas. The empirical formula is basically the most simplified version of that formula. For example, CF3. The molecular formula is the unsimplified version, meaning that that ratio could get smaller. C6F18 is the same empirical formula as CF3. This one's just telling us that we have 6 more. The ratio is the same as that one. So, if we are finding the empirical formula, we'll probably be given a percent composition. For example, we have a substance that was found. It contains nitrogen and oxygen in these percents. We're going to calculate its empirical formula. And we are going to do that by assuming that we have 100 grams of each substance. The reason that we say 100 grams is because if we have 25.9% of 100 grams, that's the same thing as 25.9 grams. So we can basically convert straight from percents to grams, which is what we do in step 1. In step 2, we are going to divide by the mass of each element. So I'll divide by the mass of nitrogen, which is 14 grams, and I'll divide by the mass of oxygen, which is 16 grams. That gives me these two numbers right here. Then step 3, we are going to divide by the smaller number. So whichever one of these two numbers is smaller, I'm going to divide by, which means I'll divide both sides by 1.85. Of course, any number divided by itself is 1, like we have right here. And this number over here gives me 2.5. And then the last and final step is to make sure the numbers are whole numbers. And here's why. If I write this formula as it is, I have 1 nitrogen and 2.5 oxygens. That's the weirdest looking formula you've ever seen. And the reason it's weird and doesn't work is because you can't have part of an oxygen. So think about this. If you have a half and you want to make that into a whole number, you would need to multiply by 2. There's a 2 up here, a 2 on the bottom. They would cancel out, and they would make 1. So what you need to do is you need to multiply everything in that problem by 2. So I'll have N2 O5 because 2.5 times 2 is 5. And so that's how we do empirical formulas. We're going to take that a step further, and we are going to calculate the molecular formula. So in order to do this, we're going to need a formula. And the formula to calculate the molecular formula is you take the empirical formula mass times x, and it will give you the molecular formula mass. We're going to take x, and we are going to multiply the entire empirical formula by x. So you'll see what I mean as we go along. The problem tells you that the empirical formula of a substance was N2O5, which is what we found in our last problem. So this could also say you found 648 grams per mole of this substance. Let's find the molecular formula. So I'm going to take my formula and I'm going to plug in the information. When I'm talking about the empirical formula mass, I'm talking about the molar mass, which you should be able to calculate by this point. If you don't remember, this is how you calculate it. You take the mass of each element times the amount, and then you add them together. So you get 108 in this case. Then I'll do the same thing. I'll take this information over here, this mass, and I will plug it in for my molecular formula mass. That means that's the mass I found. That's the mass I actually have. So then I'll plug everything into this formula, and I'll solve for x. So I'll have 108 times x equals 648. And those two numbers are both grams. If you solve for x, then 648 divided by 108 gives you x equals 6. Okay, so that means x equals 6, which means that my molecular formula is 6 times more that of my empirical formula. So I'll take my empirical formula of N2O5, and I'm going to multiply the entire thing by 6. Basically, I'm distributing. So my molecular formula is therefore N12O30. And that is how you calculate a molecular formula.